Hello, ladies and gentlemen, and welcome to Lesson 11 on water. If you could open up your note package, we're roughly on page 22, Lesson 11, Water is Special. So today we are going to talk about and learn about all the different types of properties of water. So some interesting facts about water is that the water that you are drinking today has been around for a very long time. The overall amount of water on our planet has remained the same for about 2 billion years. Therefore, that water has been recycled and recycled and recycled and has been around for so long that even maybe a caveman might drink it. Water is the only substance that is found naturally on Earth in all three of its forms: liquid, solids, and gas. Liquid as water, gas as water vapor, and solid as ice. That's pretty interesting. Water is 9% lighter ice is 9% lighter or less dense than water. And that's why ice floats on water. It's one of the only things that does that. It's really important for life because if you think about all the things that live in oceans or live in lakes or ponds, if ice formed and sunk, they would all die. Of all the water on Earth, only 2.5% of water is actually fresh, and most of that is actually locked away in glaciers. And that's why it's really bad that glaciers are melting, because as our fresh water melts and goes into the ocean, it becomes salt water, and we have less and less to drink. Approximately 66% of the human body consists of water. Water exists within all of our organs and is transported throughout our body to assist all physical functions. Our bones are 25% water, our brains are 75% water, and our blood is 83% water. It is super, super fantastic. So, also, chickens are 75% water. So let's talk about what makes it special. So unlike most things, water has a boiling and melting point that are much higher than similar compounds. So for example, H2O has a melting point and a freezing point, melting point of higher, but a freezing point at 0 degrees Celsius, okay? Whereas H2S is negative 82.3 degrees Celsius. In the world of water, we call this specific heat capacity. It requires a lot of energy to raise the temperature of water. So if you think of a nice hot beach, and as you're moving from where you're sitting off on the side across the sand into the water, the sand feels so hot and it burns your feet. And you're like, ouch, 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 as you're running across the sand. And that's because sand is got a very low heat capacity. It takes in energy, the sun's energy, and heats up really quickly, where water does not. It stays roughly the same temperature all the time. And that's really important because if you think about it, if we're made up of a lot of water, if water boiled really easily, we would probably boil from the inside pretty quickly. We also have this idea of cohesion and adhesion. So cohesion is sticking to itself. So that's water's ability to stick to itself. And adhesion means it can stick to other things. And the reason why water can stick to itself is because it's what we call a polar molecule. It has positives and negatives that attract each other all around. Adhesion, sticking to other things, is really important because if you think about water traveling from the roots of the plant all the way to the top of the plant, that's got to go against gravity. That's really hard to do. So adhesion allows for it to stick through the xylem all the way up to the flower's petals. We also learned that ice floats because it's less dense. And we also can look at water having a very high surface tension. This idea of cohesion is really important because surface tension means that it's really hard to break water and cause those ripples with small things. So this is the unique properties of water, and it also has a very unique structure. It's what we call a polar molecule, okay? The electron density is much higher near the oxygen than the hydrogen atoms. So near the oxygen atoms, you have a negative amount, and by the hydrogens, you have a positive amount. So within that entire molecule, you have positives and negatives. And what that does is it allows for it to be attracted. So if this hydrogen was floating around, it would attract oxygen. If this one was floating around, it would attract an oxygen. This would attract hydrogens. So it creates a polar structure, and it kind of creates something like this. That means because they are highly attracted to each other, because of the positives and negatives, there's a very strong attraction, and it's harder to break them apart. So this means that water molecules are strong together, and because of their partial charges, and this attraction is called hydrogen bonding, which is something that we call an intermolecular force. All right. So that is essentially water, ladies and gentlemen. You need to know the properties. So the boiling point, the specific heat capacity, the high cohesion and adhesion, less dense, and high surface tension. Those are all things that you are going to need as we move forward into the next little bit. Thank you for listening, and I hope you have a great day.